Even the simplest jobs often require more than one machining operation or MOP, so let's start with a really basic pass called a drilling pass. To get there, I will go to the Toolpaths tab and select Drill. When I do so, I have an opportunity to name that MOP. We'll only have one drilling pass in this job, so I'll just call it Drill. If you had multiples, you might choose to separate them out. The next window asks me to do the drill point selection. So when drilling, because it's such a simple operation, I could just select singular points. Although in this case, when I made the drawing, I made full circles. So we'll select those as entities. Hit End Selection. And then again, because drill is such a simple operation, we already get a preview of the movement of the tool between those drill points. Once I hit OK, a more complex window comes up, and I'll show you which parts that we're interested in. First of all, the toolpath type. We can see that there are operations related to drilling in the 2D category, so we'll leave that on Drill. Next up, I have an opportunity to establish my tool. By default over here, we have a drill bit with a 10 millimeter diameter, but I want 5 millimeters. So to do that, let's select a tool from the library, and if we're lucky, we'll find it in here. First, I scroll down until I see the drill section, and then I try to find that exact diameter and hit OK. Now, the library may or may not have tools that look exactly like the tools in your shop, so you may take the opportunity to edit these tools. And to do that, I can right-click in this window, and I can create a tool from scratch, or I can choose to edit an existing tool if it's highlighted. In this case, the tool will work just fine for us, so I'm going to leave it alone, but you'll always have that option. The same applies here for the holder, so that's just the part of the machine with the collet where the drill or the end mill is held in place. By default, we just have a plain cylinder that represents the part of the machine above the drill head, but you might choose to look at these numerical designations for more complex holders. In this case, all we care about is the representation of the distance from the holder to the tip of the tool, and then Mastercam will be able to tell if the drill ever crashes into the workpiece, so I'll leave this as the default. Next up, we have the cutting parameters. By default, this is drill and counterbore as opposed to a more complex drilling operation, so I'll leave that alone. And then finally, we have linking parameters. Sometimes the difference between incremental and absolute units can be confusing to me, so I'll switch these all to absolute. Retract has to do with the number of millimeters that the tool tip will raise up when it's traveling across the material but not engaged in a cut. 25 is probably a little generous, so I can leave that maybe more around 10. The top of the stock in this case is going to represent 0, and then our cut is going to go down into negative Z territory. We know our material is 5 millimeters thick, so I'll make that -5. Now, in addition to just barely getting to the bottom of the material, I'll also want to add tip compensation. If you're working with a standard issue drill bit, it will likely have a point that looks something like this with an angle on it. So if I just drill down 5 millimeters, that'll be 5 millimeters to this point, and I won't fully penetrate the entire material with a 5 millimeter diameter hole. I'll leave these as the default, but you may want to check your materials to see if you have a different tip angle to work with. So I'll hit the check mark, and now I'll move my view into isometric, and we can see here a preview of the cut that we're going to make. So the yellow is tool movement while the bit is not engaged in the material, and blue is the movement of the material while the cut is being produced.